Okay, we continue for the superposition method. In this method, it could be applied very widely because for example, in this case, this is a hinge here, so it looks like a very complicated. But when you use when you use superposition, when you use a superposition method, it will become very easy. This is a kind of a complicated bin and very difficult to solve. But when you use a superposition method, it will become very easy. And I will tell you how it is very easy. And the first step, you need to calculate. You need to calculate the reflection force. Actually, the reflection force is very easy to according to equilibrium equation. According to equilibrium equation, and we can calculate the reflection force is equal to 2p divided by 3. Yeah, this is from equilibrium equation. You can calculate by yourself. Okay, so for what is the superposition, it will become very easy to solve the problem, and we can look appendix similar. Use again the appendix for this case. Yeah, for this case, yeah, we look. This is our appendix from the deflection table, and we can from the deflection table, and actually we will find in this case we want to find the deflection and the deflection at the B, and we will find the deflection at the B. Okay, so actually the deflection at the B is like this. Is a distribution load. This is the table, and another is a concentrate load. Is for this table. So we can use this table and this table to do the calculation. So it's really very easy to do this. Okay, let's see. And from the table, we will calculate the deflection of. We will calculate the deflection of the cantilever beam. So is this is look like a free end. So the value is here. The delta B, the delta at the free end is this one. And here, this for this one, this is yeah, you will know the concentrator here. So the deflection here. So the similar, the data B here is here. So in this case, so we can say the data B is separated into two parts, and from this part, we can get Q L4 and EI. And replaced by the real case, the B is actually L is actually is the B by replacement, and the EI is the same. And from this table, the data we call is a data V1, and this is a data V2 due to the second partition. The second partition is a PL 3 EI, and actually the real is the P is actually is F, and the L is actually is a B, so it's a FB3 and 3 EI. Because the F we already get, so equal to 2P3 and divided by 9 EI. Be careful, the P is the P here is different from the P here. So please, I don't think it's a good. Okay, so be careful. This P is different from this P. So you just replace P by F, and the F is equal to 2P divided by 3. So this 2P is a different meaning. Be careful about it. Two different meaning. Okay. So finally, we can get the data B. The data B is equal to partition 1 and the partition 2 together. So the final answer is Q B4 and EI, and the plus 2P B3 and the 9 EI. So very easy to get the answer. Just use the appendix table, and you can get. So this is the superposition. It's a very good method for the deflection, for the superposition method. And in this case, we also need to find the theta A. We need to also find the theta A. We need to also find the angle of the A. Okay, so now we try to find the angle of the A. It's also not difficult, because for the O, we will find maybe we put thumb and the EE for understand. we want to find the angle. I think we need to enlarge. The angle actually, the angle is by two partition. One is the partition, we say theta A. Maybe we say theta A, and partition 1 is equal to due to the delta B, due to the point of delta B, and by A. What is this? Because from the delta A, the theta A here is separated into two partitions. One is due to the deflection here. The deflection here, it is the part is a forced partition. So it's a triangular relationship. The distance here is A. So the angle here is delta V divided by A. Okay. So this is the forced partition of the theta A. And because we already get the delta V, so we can easily to write down QB 4 and at A EI. At A EI and the plus 2 PB 3 and 9 A EI. Just divided by A. Okay, this is partition 1 for the angle. And what is the partition 2? The partition 2 is due to the concentrator. So we will use another table from appendix. Yeah, I put here. It's easy for your understanding. And the partition 2 is from the appendix from the deflection table, because the partition 2 is due to the concentrator. The partition 2 is due to the concentrator P. So the concentrator B will contribute the rotate of the theta A. So we will find the theta A here is a PAB, L plus B. So in this case, theta A, number 2, the partition 2 is equal to, and you can find very easy to replace every items. Is P is similar P, and actually A is in the real case is 2A by 3 divided by 3. This is the real A, and the B in the formulation actually is a third of A, because according to the real distance, and the L plus B is equal to A. The L is A here, plus A divided by 3. And the bottom, L is A, 6A EI. 6A EI. And finally, we can get 4P A square and 81 EI. I have some explanation for you. So the P is the same P here, and the A here is only the length here. So in here is 2a by 3. So a here is 2a divided by 3. And the b here is 1/3 a, 1/3 a. B here, 1/3 a. So b is 1/3 a. And L is the total length, is a. L total length is a. Okay. So you need to replacement by the real case. You need to replacement. I say, I think it's better I replace for you. Otherwise, you cannot understand very well. Oh, we just do some replacement. P is a similar P, so this is the same. And in this case, A, you need to replace by 2a by 3. This is real. And in this case, B, you need to replace by 1/3 a, because this is a partition here. And the L here, you need to replace by total length. Is in this case is a. So you just do the replacement. You just do the replacement of this, and you can get this formulation. Okay. So finally, the theta A is just a multiple of two partitions. So the theta A is equal to theta A partition 1 and the theta A partition 2. This is the superposition theory. And when you combine this all together, is equal to QB all order, and the HA EI plus 2PB reorder 9A EI, and the plus 4 PA squared divided by 81 EI. Okay, this is our final solution of theta A here, and the final solution of the delta V here, delta V here.